into it. Okay, so I am just going to step to the side over here. I have a slightly different setup today, so maybe I'll make this a little bigger. There we are, so you guys can see that. And let me just go into sorry. Okay. So we are going to go through Python functions. We're going to talk about why we use functions, what is a function, and then how to create one. How do we define functions? How do we call functions? What are parameters? What are arguments? What are return values? The scope of variables and how those are impacted, and then a couple of best practices. So again, I kind of teed up at the beginning of this why we even, what a function, the use of functions are, and it is to reuse pieces of code. So I have a particular example. Why functions? Imagine you're building a shopping cart program. We want to make a shopping cart, and we want to we want the shopping cart to do things like add items to our cart and to calculate the total and to apply discounts and to calculate the taxes. Imagine if for every single person who came to use our website or our shopping cart program, if we didn't have a function, we would have to add items for every single person that came to the website. And we'd have to figure out how to calculate the total for every single person that came to the website and apply discounts for every single person. And it would be a lot of code. We would have to repeat a lot of the same code, and the code for these, and every time we needed to do it. And say if we changed something, like we added a new tax, the city increased taxes, we had to increase it by 1%. There might be a lot of places and locations that we have to change and update that code. So instead, we use functions. So that function defines how adding a cart item to the cart works, or how calculating the total will work. So I think I have, I'm gonna do the side by side here. So we have a Python functions example notebook, and this contains all the examples from the slides. Just so you guys have some context, this is a function. What is a function? This is our Python function, which we'll talk about more. Def, we're calling it add. It's taking in parameters A and B, and it's returning A plus B. So maybe we're defining how to add two numbers together. You guys have already been working with the equivalent of that function in the plus operator. So imagine we're building a shopping cart program, and we have several tasks for it to do. So recall our shopping list here. We had milk was milk, and eggs was egg, and bread was bread, and cheese was cheese, and we wanted to print this shopping list. Imagine we want to evolve this shopping list into a shopping cart where we can actually do things, like we can add items to it. And we want to track the price for each name, so we decide to use a dictionary. So here we're going to create an empty shopping cart, and we're going to say shopping cart at laptop is $1,200, and we're going to print shopping cart. But each time we add a new item, we have to add a lot of code. So each time we add headphones, we say it's worth $200. When we add a mouse, we say it's worth $50. And there's a lot of room for error here. What if the way that I add something else, maybe all of these have 2 zeros after the decimal place, and maybe in the next one I don't do that. It's error prone, and there's some potential to introduce some inconsistency here. So instead, we create a function. We create a function called add item. So we say def, telling Python, hey, this is called the function declaration. I'm going to create, you declare that you're going to create a function. Then we have to name our function, any name we'd like it, just like you can name your variables any name you would like them. Similar thing here happens with functions. And we create a function called add item. And this function needs 3 things to work. It needs a cart, it needs an item, and it needs a price. And so we take cart at item equals price. And we add item for price to the cart. So all of this code up here we had, and then we can add each item and we can pass these values. So it takes in a cart, we pass it shopping cart. It takes in a laptop, we pass that to item. It takes in 1200, we pass that to price. So all of these, this code up here, the shopping cart laptop equals this, the shopping cart headphones equals this. We made a blueprint for that. We said, what's in common between these lines of code that we're repeating over and over again? And we said, oh, they all take our cart, which is shopping cart. They all take an item. Here it's laptops, here it's headphones, here it's mouse, and they all have a price assigned to them. Here it's 1200, here it's 200, and here it's 50. So we did something called generalize that, where we basically made a pattern, we made a blueprint, and then we said apply this blueprint to each of these items. And what that does is that enforces consistency. So we can't do it in a different way. It always does cart at item equals price. So this is the essence of a function. So now we have a function called add item to our shopping cart, and we can keep going down this path. We could build other functions too, such as a calculation tool to apply discounts. We can generalize, here we go. Such as a calculation function, we can add a calculate function, we can add an apply discount function, we can add a calculate tax function, a checkout function. And so now we're starting to have this huge program that has a lot of capabilities in it. It can do a lot of things, and we're breaking this down into components in modules of code that have their own set of defined functions. So that's the why, and just the overarching example. But let's talk a little more. Let's talk about what a function is now. I try to always give the why first. I don't know if that's helpful, but there we are. So the why use functions. What I want you to take away from that shopping cart example is just that functions enable us to break down our code into reusable components. So these are reusable things that we can plug and play over and over and over again. So their functions are reusable blocks of code, and they're typically designed to perform a very specific task. You want to have it do one thing, like calculate the taxes or add to the cart. You want to separate functions, tasks as much as you can to keep the code maintainable. The purpose is to simplify complex programs. If we had a whole complex program that did all the tax and did the shopping cart and did all this stuff, it can be challenging sometimes to test pieces of the code, and maybe we need to update or change the taxes, and we might be at risk of breaking the entire code when we make one change. So we want to take big monolithic programs, and we want to break them into reusable components. This is kind of functional programming. And most importantly, it really avoids code repetition. So there's this, I don't know if it's a theory, but there's this idea that writing more lines of code is not better. More lines of code actually probably means that you have a worse program. If somebody can do the same thing and you have 2,500 lines of code, if somebody can do the same thing in 300 lines of code, they're probably leveraging functions to be able to do that and reducing repetitive code within their program. So an example of a function, we can add two numbers together. Here's my add two numbers together function, just to keep it really simple. We can make a formula to calculate interest. We can even score the performance of a machine learning model. So accuracy is a function. If you give me what your predictions were and what actually happened in the real world, we can call accuracy. So functions are very important in machine learning performance assessment of machine learning models. A lot of benefits to functions. These are the main ones. Reusability, write once, use multiple times. Modularity, we can divide the program into different logical sections. Readability, it really makes your code easier to understand. If I just have to read your function once, understand what it's doing, and then see all the ways in which you applied it. And maintainability. So for a software team, when we have to fix issues in one place, rather than throughout the entire piece of code, Control F and fix it in every location, it's much easier to fix it in one spot, one isolated location. All right, let's get into creating some functions. So we're going to define and call some functions. In Python, a function block a function is a block of code. I'm going to get my pen out here. A function is a block of code that's defined with a name. And so here is how you tell def is the keyword, and it indicates that we are defining a function definition. So def is the keyword that indicates we're creating a function. Python doesn't know you're creating a function unless you say def. So we say def, and Python says, oh, now you're creating a function. And then in the within the function definition, this is called the function definition, by the way. This whole thing. Within the function definition, we have the def keyword, space, and then there's the function name. So the function name is what you want to call it. That's the name that you're assigning to it. Now, there are some rules about what you can put in the function name. There can't be spaces in the function name. So you notice that this says function space name. But this is how you are going to reference your function. So this is how the function, and when we say reference your function in Python, it means how the function is called. So call is what we say when we want to execute the function. Then all functions will have an open parenthesis here and a close parenthesis, and it'll have a colon here in the function definition. Sometimes there will be something in between these parentheses, and sometimes there will not. So the first line of the function definition is the header. So this is our header. This is our header. And the rest of this, anything inside of this, is our body of our function. And the body is what the function actually does. So here's our function definition header. We say def greet. We're calling our function greet. It takes in no parameters, but remember I said there was always the open parentheses, closed parentheses are always going to be here. Takes in no parameters, and we have to end the function header with this colon to tell the program that we're done defining our function. And then on the next line, we indent. Remember, Python's a indentation-based language, so we have to indent to be inside of the function. And we're going to print hello. So that's all our function does. The body of our function is to print hello, everyone. But when we define this section of code and we run this in the program, it doesn't do anything until the function is called. So this code block is only executed when the function is called. And here we are calling the function. So this is how we would call a function. We would say the name of the function, open parentheses, close parentheses, because it doesn't take any parameters. And those, so that's the function. And again, there's some rules for function names. They're similar to the rules for variable names, and you guys can look those up pretty easily. Let's see what our next. Let's look at this again, because there was a lot of red on that slide. So here we have the def keyword that's telling Python that we're going to define the function. Here we have the function name. Here's where we pass any parameters, and we're going to talk about what a parameter is. And then this is the body of the statement. And something important about functions is they can return values, so they can give a value back. So this is something called the return statement, which after this function executes, it will hand back to whatever called it, whichever line of code called it. And this is the value in this case that it is handing back. Okay. So calling functions. Any questions so far on defining functions? On how to create a function? Okay. Let me see if we have any notebook examples here real quick. Let's pop out of this for just a second. Yes, we do. Okay, so we have, imagine we want to, for some reason, make 3 plus 4 this addition process of function. And you probably wouldn't really do this, but this is maybe just a simple example I'd like to use here. So here, to create the function, we're going to say def, and then space add, and we're going to take in 2 parameters. We're going to take in A, and we're going to take in B. We're going to close this, telling the Python program that we're done creating our header for our function, and then we're going to return A plus B. Now we can call this function as many times as we want. So let's, let me come over here to this. I'm going to look to the side. It's going to be a little interesting here. So if we wanted to call add here, we're going to, the first time that we run this, notice that this doesn't do anything. There's no output that we get every time that we run this. We don't generate output, meaning we don't execute the code block until we run add. So we can do add 3, 4. We can do add 7, 8. We can call add 9, 10. We can call add as many times as we want. So we wrote this piece of code once here, and then we reused it 3 different times. So here we have our greet function. And okay, I don't want to get too far into parameters and default values. Okay, we're going to keep going in the slides here. Yeah, we're at the right spot. Okay, so we know how to define a function. We know how to create one. Now we're going to talk about how to use a function. When you use a function, it's called calling a function. You call a function. We call a function by using its name followed by parentheses. So when we define functions, they're not actually executed. They are stored in memory, and we tell the program, hey, when you're ready to run this, this is how you do it. That's what defining a function is. But don't do it yet. I'll tell you when you need to do it. So just hold on, and then I'll tell you when you need to run this function. So in this case, we're creating this greet function that says, that prints hello, and then it takes in a parameter of name, and it returns the name. And we're saying, hey, don't run this yet. I'm just going to define this for you. So notice that this print statement doesn't actually execute. If you go into that notebook and you try to run it, you'll notice the print statement doesn't execute until we call the function. Until we say on a different line, greet Alice, and it outputs, well, hello, Alice. It outputs hello, Alice. It actually executes that print statement. And then we can call the function as many times as we would like. So the function call you can do as many times as you would like. And one thing to note is that we do have to define the function before we can execute it. So if you tried to call the function before passing the function definition, you would get some type of error. So here we have our greet hello, and this here is called a parameter, by the way. We're going to talk about this very shortly. So we're creating a function called greet, and it's taking in a parameter, and that parameter is being passed to it. So it's taking in Alice, and that is how it's printing out hello Alice. It's taking Alice as parameter, it's assigning it to the variable name, and now when it prints hello name, we now see hello Alice. We can test this out by passing a different name. By passing a different name, we can pass hello Emily, we can pass Bob, we can pass Teresa, and we see the function now says hello Emily, it says hello Bob, it says hello Teresa. So we're getting some dynamic functionality by passing in a parameter and having the function behave differently based on that value that we're passing it. We can put a function inside of a loop. Last time we learned about conditionals, control flow. We can actually put this function inside of a loop, and we can say for I in range 10, we can call greet at I, and we're actually going to call this function 10 times. So hello 0, hello 1, hello 2, hello 3, all the way up to hello 9. Remember how I said the function definition has to be executed before the function is called? Let's say we created a new function called def my new function, and all it did was print hello. If we tried to call the function, this is calling the function up here, before we define the function, this is defining the function down here, we're going to get an error statement. So we're going to try to execute that, and it's going to say name error, name my new function is not defined. So we do have to define the function before we can actually use it. I guess question for you guys, how would you fix the error above? Maybe that was a question I was supposed to ask.
Go back.
Go back. Tell me more.
So re-enter the function.
Re-enter
the error.
Re-enter the function. What should we put on the first line here?
The greet.
The greet.
Which is my new function.
My new function. Yep. This definition part?
Yes.
Yep. You got it. So we're going to, we're going to change the order and put def and then call my new function. And now it will work.
Is that still considered the greet or the def?
Oh, that's a good question. This is the definition, and then this will be the function call.
Okay.
Okay, let me see what my next slide is. Any questions on calling functions thus far? I'm going to have you guys try it out. Sorry, we just did this I have this content on the slides and in the notebooks. They go side by side, but we just did this in the notebook. So I want you guys to try it. I want you guys to spend 5 minutes and define a function that prints, this is the function. And then I want you to call the function. Say 3 to 5, maybe just 3 minutes. I don't think you need 5 minutes. Let's do 3 minutes. There we are. I remembered my charger today.
I forget mine's a lot too. Well,
I have 2 in my bag now.
my tab.
I should figure out how to set timers on here. I'm sure there is that capability. Okay. Does anybody want to share their code? Let's move this mouse over. Okay. Let's create a function that prints this is a function. So let's create a function. First, we're going to put def. Def is the, I'm going to call it, def is the function declaration. I'm going to call it uTryIt function. And we're not going to take any parameters in. Then we're going to put our colon here saying that we're done. We're going to hit enter. And our cursor automatically is indented, which is great because the code inside of the function has to be indented. And then we're going to print, this is a function. And we're going to run that, and it doesn't do anything because we declared the function, but we didn't call it yet. So that's the function declaration. And to call it, we would simply do uTryIt function, ending with the parentheses, and then we get the results back. Okay. Function parameters and arguments. What are those parentheses for, and what are those values that we're passing to those parentheses? What do they mean, and how do they work? Well, you've actually been using functions in Python for a while in this class. You just didn't know that's what they were called. Some of the built-in functions that we've seen in this class are the type function. When you say type and then you pass it a number, 1, 2, 3, and to check what type that variable or that object is. We've seen the casting function. When you cast, you have int and you pass it a number or a string that you would like to attempt to cast to an int. And math functions exist in Python. So when we import math and we call math.sign and pass a number to math.sign, we're using functions there as well. In these examples, these functions are each taking one argument. Functions can actually take more than one argument and can be very complex, sophisticated pieces of code. We're just oversimplifying and looking at a simple piece of that. But the arguments are assigned to variables called parameters, which enables functions to operate dynamically. What is a parameter? Functions can take in data known as parameters. So here's a parameter for our function. Our function is called greet, and it takes in the parameter name. And then it prints out hello, and then it dynamically substitutes the value that it has associated with the variable name into that print statement. So variables are defined in the function definition, and the function assigns the argument to parameters when the function is called. So these are our parameters. When we say parameters, we're talking about this piece here. This is where we're defining and declaring that parameter, which says this is what this function needs to operate. And then this is where we're using that parameter inside of the function. We don't have to just use it once. We can use it more than once. Arguments, on the other hand, are what we're passing to the parameters. You can think of this as the value. So you know how in code we have var equals, we had this variable, and then we assigned it to some object value. Maybe it was, I'll just use the Alice example. Equals Alice. We had var equals Alice. That's basically what we're doing here. But instead, we're saying our parameter, which we're calling name, is equal to this argument. So we're saying our parameter equals our argument. So this is the value. Alice is the value that name will take on, that the variable name will take on this value of Alice. So every time we use name in the function, when we call that greet and we pass Alice to it, it's going to substitute that with Alice. Of course, if we said after that greet Emily, then it would substitute it with Emily. So that's the value and power of functions. So we can pass data, so arguments, we can pass data, known as arguments, to the function. And these values are passed to the function when we call it, and these arguments get assigned to parameters. So the arguments get assigned to parameters, is what I was trying to dictate up here, and inside of the function. So when we pass Alice to the argument in the function greet, it gets passed to the parameter name, and name takes on the value of Alice. If we passed Emily, Emily would take on the value of Alice. Yeah, of course. Now, there are such things as default parameters. So what if we're getting into some, so that's the basics of functions. Honestly, if you wanted to build functions and use that, you're good. The rest of this information around functions is like extra stuff that you're going to see. If you guys can just work with function calls, definitions, and parameters, you're sitting in a really good spot. Now I'm going to show you a few things that as you see them in Python programming, you might say, well, what is that? And why? What does that mean when I see that? So think of these as extra things. When a parameter does exist, like this, if we say def greet name, you must pass an argument. So for example, what we couldn't do here, you'll get an error if you try to call greet and oh no, we didn't pass an argument for our parameter of name. So we have a parameter of name and we didn't pass an argument. And we'll get an error. It'll say, hey, greet is missing one positional argument, name. We didn't pass a positional argument when we called the greet function. But what if you wanted it to have some default functionality? What if you wanted your function greet to just say, hello guest, when you don't pass a name? Python has some syntax for that, and you can leverage something called default parameters. So if you want a function to hold a default value to be used when no argument is passed, we can assign a default function inside of our function definition. So remember, our function definition is this piece here. And what we can do inside of our function definition is we can say name equals, and we can assign a default value. So we're saying name equals guest. And now, look, when we call greet, we're not getting an error, and we don't pass any argument here. We're not passing a positional argument. We're not getting an error. Because name, our parameter of name, is taking on the value of guest when no positional argument is passed. So now here it says, well, hello guest is the output here. So this is how you would assign a default parameter. Let me see. I'm sure I have that in the notebook. Let's look at the notebook, and then I'm sure we'll do a you try it right after this. Okay. Let's example number 2. We have this parameters in default. So just to reiterate, we have this parameter name, and we can pass, it takes on that, we can use that value name. When we pass Alice as an argument, the parameter takes on the value of Alice. When we pass Emily, it takes on the value of Emily. When we pass student 1, 2, 3, 4, 5, it takes on the value of student 1, 2, 3, 4, 5. Variables can also be passed as an argument, by the way. It doesn't have to just be string. So here I'm calling greet, and I'm passing a string. We can also create a variable called myVariable, and we can assign Bob to the value of myVariable, and we can pass a variable to the greet function. So we can say greet myVariable, and now it says hello Bob, because myVariable points to get stored in name, and when name calls myVariable looks up what its value is, and it finds that the value that's been assigned to it is actually Bob. In this case, we talked about if we try to call this, we'll get an error because, oh no, greet is missing one positional argument. The way that we can fix that is defining a default parameter. So here, instead of just saying what we had before was guest was this, and this throws an error. Instead, if we want our function to have a default parameter, we can put an equal sign after our parameter, and we can give it a value. So we put an equal sign and we gave it a value of guest. And what this is saying is when nothing is passed here in the parameter as an argument to our parameter, then I want you to print hello guest. Now, what if we did have something here? What would happen? Let's look and see. Oh, it would just overwrite our default value. So the This is just a default value, but if there is a parameter to pass, an argument to pass that parameter, it gets overwritten. Okay. I want you guys to try it. You try it here. Parameters and arguments. Write a function called meal cost with 3 parameters. I want you to take in price, tip percent, and tax percent, and calculate the total cost using total cost equals price plus price times tip percent over 100 plus price times tax percent over 100, and return total cost. Try the function out by calling it, passing some values. Call meal cost, say it was $50 and it was 15% tip percent and 8% tax. Try it on 10 and 5 and observe the output. I think that's enough for that one. If you want to try a bonus challenge, I should have put the default parameters as a bonus. For bonus, you can try to add the default parameters. So I will give us a few minutes on this. I'll give us 5 or 6 minutes. I'll give us 7 minutes on this because that gets us to 7 o'clock, a nice even round number. We'll come back. We'll talk about this, and then we'll take a break. Oh, we're not on a break. We are spend 7 minutes.
This is a presentation about the mind-gut connection. The title of the paper I will present is
All right. Let's go ahead and create a function called meal cost. So def meal cost. And we're going to take in 3 parameters. The first is going to be price. The next is going to be tip percent. And the last one is going to be tax percent. And we're going to create these. We're going to create a variable called tip amount equals, we're just going to use this, price. So we're using our definition, total cost equals, we're actually going to, we broke this down into pieces. So tip amount equals price times tip percent divided by 100. Tax amount is going to equal the price of our bill times the tax percent as a percentage, so divided by 100, and our total cost is going to be price plus tip plus tax, and we're going to return total cost. So we created our function definition, and now we need to call our function. So let's call meal cost. We're going to pass 50, we're going to pass 15, and we're going to pass 8. We can see that it's 61.5. It gets kind of confusing when we start adding multiple parameters in here. I will tell you that Python is order-based, so 50 gets assigned to price, 15 gets assigned to tip percent, and 8 gets assigned to tax percent. If we wanted to be more explicit, though, if we wanted this to be a little more readable to humans, we could say meal cost, and we could say price equals 50. Tip percent equals 15, and tax percent equals 8. These two things are going to do the same thing. The second line is a little more readable. Doesn't change any of the functionality of the program, but now we know that 50 is getting assigned to price, 15 is getting assigned to tip percent, and 8 is getting assigned to tax percent. So what we can do with that is we can change around the order of that if we really want to. That's a bit of a rabbit hole, sorry. So this makes it more readable, a more readable program. Next, let's try another one, another example. Let's say meal cost, and we're going to pass price is equal to 30. We had a $30 meal. We're going to tip 10%. Maybe it was a buffet or something. And the tax percent here is just 5. And now we can see, sorry, I just realized I still have this thing on here. There we are. And now we can see that we use the same code here twice. So we didn't have to redefine how to calculate a tip and how to calculate tax and how to add all the costs together. One block of code, and we used it twice. We can use it as many times as we'd like. If we wanted to modify the functionality to give a default value for, let's see, modify meal cost to give tip percent a default value of 15 and a tax percent a default value of 8. So let's modify this. Tip percent is equal to 15. Tax percent is equal to 8. And now if we have our bill, we can call meal cost price equals 30. Oh, I have to rerun this. I changed the code, but I didn't execute the cell, so it's still using my old function. I have to run this cell to update the interpreter with the new function. Now we can meal cost price equals 50. We can use this, and now we're just passing price, and it's assuming default values for our tip percentage and our tax percent. All right, let's go ahead and take a short break here. Let's take a 10-minute break, come back at 7:15.
I have a question. This is Nancy.
Yeah, of course.
can we store these functions somewhere so that we can call them? Or do we, I don't know how to ask.
That's a great question, Nancy. Yes, we can store these functions somewhere so that we can reuse them over and over again. And that's what Python packages do. They basically take
Okay.
functions and they store them somewhere that we can pull them in and reuse them. And we're going to learn about that here very shortly.
Okay, thank you.
It's a very relevant question, Nancy.
Thank you.
We're talking about Chicago and good places to visit there. If you guys have tips, definitely drop them in the Slack channel. Okay, I have one more topic to cover here on Python functions, and that's return values. And then I'd like to touch on an advanced topic, which is variable scope, but don't worry about it too much. I just want you to be aware of it as you might see it and come across it. But return values are definitely a critical core component of functions. So when we're talking about return values, we're talking about the data that we're getting back from a function. So far we've done these functions that print hello world and do things, but they haven't necessarily returned us anything except our addition function. Functions have a very core capability to return something. So functions can return results to the caller. So whatever is calling your function, it can actually return the results. In this case, we have our addition function, our really simple add function that we created. We create a function called add, and we're calling it here, this function. We're passing it the value 3, 4, and the results of that is that it'll take 3, it'll assign 3 to A, it'll assign 4 to B, and then it'll do 3 plus 4, A plus B, 3 plus 4, and that'll take on the value of 7. And 7 will be passed to the return, which is then what gets replaced here in this function here, in this entire segment. So result now takes on the value of 7. At the end of this, result takes on the value of 7. That's because functions can return a value. So and it returns a value using the return keyword, and that's what actually sends the data back. When we're working with functions that we're printing hello and printing a name, in Python, not all functions have to have a return. They implicitly return none. So if we would have tried to say assign a value from one of those, we can just try it here. Instead of me trying to verbally say it, sorry. Trying to verbally say that. Let's look at it here. So we have this function, and if we look at add, we can see that it's getting back 7. So if we say my var equals add 3, 4, and then we print my var, we can say my var is now takes on that value of 7. Now, when we were working up above and we were doing all of these greet statements, this did not have a return statement in it, for example. And I just want to show you that the default value is none. So if we created this one and we said my var is equal to greet, and we asked it to print greet or print my var. Oops. Greet. I have a typo in here. Print. I have 2 typos in here because I'm looking at a screen that's relatively far away. Oh, I have this indented into my function, so this is an indentation error. I'm going to unindent that. There we are. So we say, you can see that when we print, this first print statement is coming from this hello name, and that's happening inside of the function. But when we're assigning the value of the return value to my var and printing my var, you can see that we're getting none. Okay. What is none? This is probably a good time to talk about the none object. So none is an object in Python. that's a special built-in constant, and it represents the absence of a value. If you guys came from the SQL world, you came from a SQL class, this is Python's equivalent of a null value. So instead of saying null, we just say none. I just want you to be aware that the none object exists in Python. It's a keyword. You can see it's highlighted blue when we try to use it in Google Colab. And it's its own data type. So we talked about strings, we talked about integers, we talked about lists. Those are all data types. None is its own data type. It's called a none type, and it's usually used for indicating nothing or no value. So we have to have a way in the world, we just indicate no value with the absence of something. But in programming, we have to indicate the absence of something with an actual data type. And that's what none represents. So a couple other facts, it evaluates to false and Boolean expressions, but it's often used in functions as default parameters or to check for missing values. So you may see the none object out there. It's very common. I just want you to be aware of it. And it's the default value that's returned from functions when there's no return value. So in this one, we have a return value, but if we had no return value in our function, it's the default. Okay. Go ahead and try it out. I want you guys to try out the return function here. So spend 5 minutes, create a function called convert to Celsius, and it's going to take in one parameter, and that's Fahrenheit, and convert that to Celsius using the formula. And then return the Celsius value. And then you're going to go ahead and test the function and then use a return value. Spend 5 minutes on this. I apologize, I was on mute. This is just saying that functions can return more than one value. I've got to get over this right screen here. And this is demonstrating the none element. Okay, let's try this. You try it. So our goal here is to write a function called convert to Celsius. That's the first step. So write a function called convert to Celsius. We're going to say def convert to Celsius. If I can spell. And it's going to take in one parameter called Fahrenheit. So it's going to take in one parameter called Fahrenheit. Oops. AI is trying to help me, and it's making my life harder. There we are. Fahrenheit. And then we're going to get into the block of the code here. And in the block of the code, what we actually want this function to do is to convert Fahrenheit to Celsius. And the formula to do that is Fahrenheit minus 32 times 5/9. And so we're going to create a variable called Celsius. I will just use this. And we're going to say equals Fahrenheit minus 32 times 5/9. And we're going to return Celsius. So we're going to apply this conversion to our parameter Fahrenheit, which is an argument that has to be passed to the function for it to work. We're going to store that into Celsius, and then we're going to return Celsius. So here's our def convert, our function convert to Celsius. And let's test this function. Let's try to convert 100 degrees to Celsius and 32 degrees to Celsius. So let's convert to Celsius, 100 degrees. And remember, we can actually pass the name of the parameter that we're passing if we want to. So we can say convert to Celsius Fahrenheit equals 32 degrees, and that's 0. So 32 degrees Fahrenheit is equal to 0 degrees Celsius. 100 degrees Fahrenheit is equal to 37 degrees Celsius. And here we want to use the return value, so write another function called isFreezing that takes one parameter Celsius. So we're going to write another function called isFreezing, and it takes one parameter, which is Celsius, and it returns true if the temperature is below 0. Otherwise, it returns false. So if Celsius is less than or equal to 0, it returns true. Otherwise, it returns false. Let's try this out. So isFreezing. Let's pass 0. We get true. isFreezing. Let's pass -5. We get true. isFreezing. Let's pass 10. We get false. Use convert Celsius inside of isFreezing to determine if 32 degrees is freezing. Okay, so isFreezing takes in Celsius, and convert to Celsius takes in Fahrenheit. So we can say isFreezing, and we can pass in convert to Celsius, and then let's pass in 32. And now we're able to pass in 32, which is a Fahrenheit value, into our convert to Celsius function. It will convert this to Celsius, return that value, and then that value actually gets passed to the isFreezing. So it almost becomes like a chain of operations. That's kind of a little more sophisticated piece, but I just wanted to take that. Maybe I should have put that under the bonus section.
Can you scroll up a little bit?
Yeah, of course.
For the original.
This one.
So why did you use the add 5/9.
Why did I use the what?
Why
Sorry. Why didn't I use 5/9?
above.
Which of these cell numbers?
You used 5, but you didn't use 9, you used 10. So if you scroll above,
Oh, yeah.
when the first function
Oh,
converted,
5/9, yeah. Why did I use 5/9 here?
right, 5/9, why didn't you use that
Oh, use this.
to create a function? I'm curious, because I see you use 32, you used 5, 0.
That's what
When
you need
the
to do
converted-
that's how you need to do convert to Fahrenheit to Celsius. It's the formula to convert the net formula.
I see what you're saying. So these are my that's a good question. So these are my test cases. I'm passing, we have this convert to Celsius, and this is where we're just declaring what is this function. And then this is what the function is actually doing. It's taking a number, it's taking in Fahrenheit, which will be a number essentially, subtracting 32 from it, and then multiplying it by 5/9. This is our, the world's formula for converting a Fahrenheit temperature to a Celsius temperature. So I could test with 5/9. I could say convert to Celsius 5/9. And 5/9 in Celsius would be negative. 5/9 of a degree in Fahrenheit would be negative 17 degrees in Celsius.
So you are able to use it.
Yes.
That's, I guess.
Yeah, I think you're connecting the dots. We can test any value that we want to, any numerical value that we want to pass here. Okay. Last, maybe I won't say bonus content, but like extra, like stretch content. I'd like to talk about just very briefly local and global variables, because I do think it's important. When you create a variable inside of a function, it's a local variable, which means that it only exists within that function. And after you're done working with that function, it's gone. So here in this example, we have def example x equals 10, print x. That x is a local variable. So this is local scope. So this x exists and is known to this function, but it is not known globally to the program. So a local variable are variables that are defined inside of the function, and they're accessible only within that function. So here in this example, I say def example, x equals 10, print x. And then if I try to print x outside of the function, this is now outside of the function because the indentation's on the outside, we're going to get an error, and it's going to say x is not defined. So when the function terminates, that local variable is destroyed, and when we try to print it, we'll get an exception. Parameters are also local, FYI. Something called global scope is when we define variables outside of the function. So this is a global variable, this x equals 10. And even though def doesn't have an x in it, this def example, even though we didn't put an x in here, we didn't define an x, we're going to call print x, and it's still going to work just fine. And that's because this x, it's actually going and it's grabbing our global variable. So global variables are defined outside of functions, and they can be accessed anywhere in the program. We can use the global keyword. You don't really need to worry about that. While they can simplify certain tasks, just be careful with global variables. Overusing them can make your program really complicated and can introduce errors that are really challenging to debug, because honestly, you don't know where it's happening at. So I would use local variables to the extent that's reasonable, and keep global variables to a minimum. If I had a best practices to recommend, which I think I do at the end. We're going to skip the you try it because we're going to keep going. That was kind of just extra stuff. So best practices for you guys to keep in mind: use descriptive function names as opposed to just saying X or Y or Z. Keep functions small and focused on one task. Avoid any side effects while possible, such as when you're working with global variables. And something we can talk about another time are doc strings, which are ways of telling other programmers what your code is doing. So you can create these doc strings, which are just text. When you put words between 3 quotation marks, so we have quotation, 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 and then we have quotation, quotation, quotation. Anything in here is ignored by the program. So this is not code. It doesn't get executed. This is just something called a comment, and it's something called a multi-line comment, and it enables us to just tell other programmers, hey, I made this greet function. Here's what it does. It accepts these types of parameters, but that's a bit of an advanced topic. All right, I have a recap slide for you guys if you guys find that useful. I'm going to keep this. And we're going to switch to Python libraries. Great. So functions seem useful. What if we took it to the next level of generalization? Obviously, there's a lot of very smart people on the internet building really cool things. Somebody earlier, I think it was Nancy, asked, how do I save these useful functions to use them later? And we're going to talk about that here with packages and libraries, things that you can import that somebody else has built that function, or you can create your own package or library and import your own functions. And use that, take advantage of that reusable code. So we're going to talk about functions. I may not get through all this. I just want to focus on what libraries and packages are, and a couple of the packages that are most common for exploratory data analysis and visualizations. And I think next class we'll get hands-on with it. So we'll do our hands-on activity. We'll actually analyze a data set using these packages and functions. And this is where, now that you guys know all the underpinnings of variables and functions and how all these things work, you can start to apply it to these, to some real world examples now. We've gotten through enough of the foundational content, which is very exciting. So packages and libraries. This is how we're going to use open source code from other developers. We're not going to reinvent the wheel every time that we try to do something. We're going to use the resources that are at our disposal. So imagine you're working for an e-commerce company and you're tasked with analyzing customer data to understand sales trends and improve marketing strategies. And this data set contains thousands of rows with information on customer purchases, ages, locations, payment methods, and you want to calculate the average purchase amount. Well, that's a lot of code. We have to program our own method to perform a generally useful function. And this would be, if we had to program our own method to perform a generally useful function like this, this would be error prone. This would be very time consuming. It would be inefficient on large data sets. So here's an example. What if we had to calculate the mean? So we had to create a function to calculate the mean. And we'd say if length is numbers is equal to 1, return none if it's empty, and calculate the total and the count, and then grab the mean. And we're giving it our data, our quote unquote thousands of rows. I just did a short thing here. And we're saying, hey, calculate the mean and use my function that I did to calculate the mean and return the mean. That's a lot of code. What if it breaks? What if there's holes in it? What if there's errors? This is not the most efficient way to do that. I know there's more computationally efficient ways to do that. This isn't going to run very well on large data sets. It's going to be super slow. So instead of doing that, why don't we just look to somebody on the internet who has figured out how to create the best way to calculate a mean? They're a really heavy programmer. They probably have this written in C or some other language that runs more efficiently. That's where our packages come in. Instead of us writing a function to calculate the mean, let's leverage pandas. So in pandas, we can do import pandas as PD, and this is just nomenclature. You can import pandas, and we're going to read in our data. Here, we're going to say data equals pd.readCSV, and then we're going to call pandas once we have it in pandas. Pandas is a package, by the way, that allows you to put data into an object. Remember, we talked about everything's an object in Python. It has its own object called a pandas data frame. So instead of putting things into a list, we can put it into a pandas data frame. You can think of this as the equivalent of like an Excel spreadsheet, where we have rows and columns. It's the Python programming equivalent of Excel spreadsheet. So we can put this data into a pandas data frame, and once it's in a pandas data frame, we call .mean. And then we're taking the mean. We're taking the average of purchase amount of the purchase amount column in our data set. And this is very easy to do. And now I know that when I run mean on my code, it's the same as you running mean on your code because you use the pandas package. It's which I'm getting ahead of myself here. But standardization. I'll just jump to standardization since I'm getting. What's the advantage of doing this way? The libraries allow us to follow the best practices for ensuring reliable and efficient and stable implementations. We can minimize the potential of making an error because there's lots of people on the internet who have reviewed this mean and corrected it. I have a, you guys know I go on tangents sometimes, so I have a fun story. When I was in college, had to do a senior project, and for one of my classes, it was actually for my Python programming class. I was actually learning Python for bioinformatics, and the teacher said we could either do a senior project or we could make a bug fix pull request to an open source code package called BioPython. And, I mixed this up with sklearn. Sorry, that was another story. This is a different story. I totally got distracted. Standardization, best practices. Okay, when I was implementing a project, I was using one of sklearn as a project we use for machine learning to evaluate machine learning models. And I was using sklearn for a project. And one of the things I was doing was trying to describe to stakeholders the different ways that these metrics were calculated. So I had a data set, and I had a expected output, and then I had the metrics I laid out for each one. And one of them I noticed was reporting wrong. And every time I ran it, I just thought, I'm doing something wrong. I'm passing the data set wrong. I don't understand why this metric is coming out incorrectly. It was a coefficient metric. And I went into the code, the open source code, and I found that there was a bug and that they were actually doing it incorrectly. So I got to make a pull request and actually submit that to fix the code. And then it was better for somebody else in the future. So there's lots of people who are working with these metrics every day. So instead of us having like our own simple error that we're introducing into things, there's people like myself and other people on the internet who are looking at these and making corrections all the time. So standardization, it's usually pretty good. Also, man, it's a lot of time to try to like write a function to calculate the mean and write a function to do this. So if we use packages, we can have focus. It's like using AI in your work. We can leverage packages to enable us to focus on what's important, the problem solving, manipulating the data set, how we want to design the approach. And it's usually the packages are a lot more efficient than what we could write ourselves. I'll speak for myself, I guess. What I could write myself, usually they're a lot more computationally efficient. So, all right, that was my whole tee up for packages are great. How do we, now you guys are probably like, how do we use them? So let's get into that. All right. I don't know if there's supposed to be a picture here or what that's missing, but libraries. A Python library is a collection of pre-written code, so it's a package versus a library. A Python library is a collection of pre-written code that provides reusable modules for us. So somebody asked, how can we use those modules? And these modules, or how can we reuse our code? That's going to be through libraries. These modules have really specific tasks, and they can save us a lot of effort in writing code from scratch. So we're not going to reinvent the wheel anymore. We're going to leverage packages, libraries and packages to do that. We're going to talk about it particularly through the lens of data visualization and data manipulation, because I know you guys just came from the SQL course. As you go into machine learning, that's all we use, our libraries and packages. We use sklearn, we use TensorFlow. And here in this section today, I'm going to introduce you to like some library names that I think are going to be very notable and useful for you guys.
So sklearn is like the base package, but then you can add any function that's added to the package.
You got it. Yeah, sklearn is like our foundational machine learning package. So if you want to build a random forest, they have a random forest object in there for you that you can use. If you want to build a logistic regression or a linear regression, they have objects in there for you. They also have functions for pre-processing. How do we pre-process our data sets?
You're talking about the crowdsource function, or you're talking about the sklearn?
Those are all in sklearn.
Oh.
Yeah.
Oh, that's just the repo for
All the functions, yep. Okay, so key features. I think I already beat this to death, so I don't. Here's a summary slide for you. Reusable code, task-specific solutions, really easy to use, and community-driven. Those are some good things about packages and libraries. Okay. Package library, what's the difference? A library is a collection of reusable code that simplifies a task, and a package is a structured way to organize our code and modules and bundling related functionality together. So oftentimes when you look at these things like sklearn, you'll see like pre-processing is one area. So you'll see when we import things, if it says from sklearn, some particular area, import this, it's just a bunch of file directories and folders underneath of that. So you can think of a library as a toolbox with many different tools, and a package as a well-organized drawer system within that toolbox. Okay. I want to get to okay, we're going to keep going. Packages versus libraries, this is fine. But we're going to keep going. I want to get to the actual libraries. Okay. Exploratory data analysis. Man, I had a lot of introductory slides in here before we actually get to the packages. So just I'm trying to figure out why am I. Oh, because I'm going to scope down to what we're going to talk about today. That's right. So I come from data science. My background's in data science. So when I talk about Python programming, it's always going to be the application of data science. And so today we're going to talk about EDA, and I'm giving you the context of where what we're talking about today fits into the overall data science lifecycle of building a model. There is a lot going on outside of just the EDA. So first you have to define, there's kind of this data science lifecycle. I'm oversimplifying it, but these are some probably key steps. First, you have to define the problem. You have to sit down with business and say, hey, you want to predict churn? What does success look like to you? If I could hand you churn today, like what would you do with that information? Would you call the customer before they were going to leave? What would you do with that? So you have to sit down, identify the goals, identify the success metric, and then go through this whole process of gathering and collecting data. You have to clean the data, ensure it's accurate and consistent. And that is everything. A lot of these things come from experience. When we talk about how do you define a problem? How do you do the actual data collection at your organization, and knowing what data means at your organization. A lot of that comes from experience. But data collection and cleaning, that's everything that you guys covered in the SQL course. So all of the select statements from, where, there's a little bit of overlap in these things. Today, we're going to talk a little bit about data prep. So we're going to talk a little bit about packages that you could use to perform data cleaning and exploratory data analysis. So once you have your data collected, you're going to need to clean it. You're going to need to process it. You can do that in SQL, or you'll see that you can do that in Python. Or maybe you do some of it in SQL and you do some of it in Python. What Python's really great for is that exploratory data analysis. Let's create some charts. Let's create some visualizations. Let's see how this data is changing over time, what it looks like, what it feels like. As we get to the future courses, we're going to talk about ML model building, your 2 machine learning courses, the Introduction to Machine Learning and the ML model eval covers this for each section. So feature engineering, model development, model evaluation, and then finally ending with the API class is this purple one. So talking about how do we actually deploy a model, and then how do we monitor and we maintain it. So pretty cool that your whole certificate actually covers the entire data science lifecycle, with the exception just that first blue section is just experience, and you can gather that honestly from doing small projects along the way as well. So we're going to talk about data prep, the red section. That was the whole context and tee up for that. Oh, there we go. Yep, red section. Sometimes I forget the animations that I put on these slides. They surprise me. Okay, exploratory data now. So what is exploratory data analysis? EDA, exploratory data analysis, sometimes called EDA. It helps data scientists make informed decisions about feature engineering, model selection, cleaning steps. It ensures the data is suitable for analysis in our machine learning models. So you guys probably talked about some of these things in your SQL course, created some of these visualizations. The idea behind this is to gain some insights, detect some patterns, summarize our data. So we're gonna create some charts and things that would help with that. We really want to understand the data structure. We want to understand what characteristics are made up of the data, so we can make decisions based off of that. So if we're looking at one column and we find that there's an overwhelming representation of a particular value for our target variable, we may need to oversample or undersample to have equal representation in our data set so our model doesn't have bias. But we wouldn't know that unless we had explored the data and actually understood the data. Okay, this is the slide I was waiting for. Now we're in some of the content. Pandas. So the first thing we're going to talk about is Pandas. Pandas is an open source library, and it's probably one of the most popular libraries used for data analysis and manipulation. And actually, we have a data science community of practice at my job. And one of the individuals on my team just gave a presentation to our data science community practice earlier this week on Pandas. So I thought it was really important that everybody knows and understands how to use Pandas. It's probably the most commonly used package to store our data objects in data science. The core piece of Pandas, what makes Pandas Pandas, are these data frames. So you heard me say that just a little earlier. And what a data frame is, sometimes they're called DFs. What a data frame is you just imagine you have data that's in some Excel-like format. Where we've got our columns, maybe C1, C2, C3. So we've got some different columns. And maybe we've got our rows, row 1, row 2, row 3, row 4. Pandas just stores that into a data frame. So that's typically in as nomenclature. Nomenclature meaning it's not enforced. You don't have to do it this way, but as you read things online and as you're reading tutorials and such, you'll see oftentimes data frames referred to as DF. People assign their variable names as DF or my DF or this DF. DF means data frame. And here, the way to use pandas is you import pandas. So we'd import pandas. If you want, you can, another nomenclature thing is to say as PD. As PD just says, I'm going to rename, instead of saying pandas, I'm going to rename it as PD. So anytime I call PD, it's the same thing as calling pandas. It's just people like to shorten things. So it's just a naming on top of the pandas. So pandas is made up, the most core element of pandas is its data frames, which are made up of series. Each column here is a series, for example. So this has series. That was terrible handwriting, sorry. I was supposed to say series. Which allows us to clean, structure, organize our data really efficiently. People like pandas because it comes with built-in functions. For example, this is pd.readCSV. We don't have to create a brand new function for how to read a CSV or how to read an Excel sheet. What if we want to convert an Excel sheet to pandas? What if we want to convert a CSV to pandas? Somebody else already did that, and we just get to use it. So we just get to call pd.readCSV, and we pass in our CSV file, and it converts it to a pandas data frame. So simple. One line of code. Hopefully I'm convincing you guys packages are great and Python programming is great. So this is, I have a funny story about pandas. Again, one of the most important packages, and I think it was pandas, I'm pretty sure. When they were coming out with the O'Reilly book for this. O'Reilly is a publisher that produces programming books and other books. There's this guy that holed up in New York to develop this Python program, this Python package for 2 years, and he wanted to put the panda on the cover of the Pandas O'Reilly book, and O'Reilly told him, no, we're saving the panda for something really important. So there's a mongoose on the cover. And actually, pandas now, fast forward to today, it's like the most important package in data science. So it's kind of funny looking back. They should have put the panda on it. So key features. Key features is the data frame, which is two-dimensional data structure. It's similar to a spreadsheet or a SQL table, and it's made up of one-dimensional arrays called a series. And it makes it really easy for us to do things like handle missing data, see how many duplicates there are, check for inconsistent formatting, filter, group, merge, aggregate, like everything that you want to do to manipulate like an Excel sheet, you can do that in Pandas. And it's really friendly and it's really nice. It has integration with CV, Excel, SQL databases, JSON files. We don't have to worry about a lot of that. We just leverage the built-in functions. And it has mathematical operations like means, statistical operations, logical operations. We can quickly summarize. It has a few summary functions. It's maybe not the best visualization tool. We'll look at some slightly better ones, but it does have some basic built-in visualization characteristics. Okay, let's look at how to use it. Great, all these things I've sold you on it. What does it actually look like in the wild? Pandas makes it really easy to read data from a variety of formats. So that's the first thing you're going to want to do. When you're doing EDA, you got to get your data into your Python program. Your Python program has to point to that data somehow and then convert it to a format where you can manipulate it. We can use Pandas to do that. In order to do that, you're going to need to import Pandas as PD. And then we can do df equals pd.readCSV and pass your CSV file. We're going to open up an example and do this. So this pd.read CSV. There's also pd.read cell. There's pd.read JSON. There's pd.read SQL, where PD is referring to pandas. So all of these functions are ways that you can read CSV files, read Excel files, read JSON files, read SQL files. These are ways that you can take your data and get it into your Python program so you can start to work and manipulate with it. Once it's in there, we can start using some of these functions associated with pandas. So pandas has something called a head function, which displays the first few rows of the pandas data frame, the first 10 actually. We can use a info function to get a summary about our data set. We can use a describe function to get some basic summary statistics about our columns. Let me see if I have this. Nope, we're going to go 2 more slides and then there's a you try it. So here's an example of a pandas data frame. I'm realizing this slide should have been like 2 slides earlier because we've been talking about this and it might have been hard to grasp. But here's a pandas data frame. It's a 2-dimensional size mutable tabular data structure. And it's similar to our spreadsheet in Excel, etc. So here is our customer IDs. We have some column names here: customer ID, name, region, purchase amount, age, payment method. We have some rows here, and we have some values in each row. So this is what that might look like. What's cool about this data structure, there's a lot of advantages here. One is that our rows and columns have labels associated with that. So there's a function we can actually call to get the column names. There's a function that actually tracks the index of each of our rows here, which is substantially useful. And it's heterogeneous data. So notice that they're not all the same data types. These are clearly numerical, where other ones are string values. We have flexible indexing, and there's built-in integrated functions, and we can read and write with this. How do you create one? What if we wanted to create a data frame? We're just going to make some with some fake data here. We're just going to make up some data. In pandas, there's many different ways to create a data frame. There are several different ways to the same thing. I'm going to show you one way, which is creating a data frame from a dictionary. Again, lots of different ways to create a data frame. There's a whole post on it here. I did share the link with you. So this is not the only way. I don't want you guys to feel like you have to manipulate everything into a dictionary and then the dictionary is the only way. Lots of different ways to create a data frame. If you can think of this would be a useful way to create a data frame, it probably exists. You can create it from a list, but we're just going to ground on one thing so we can start to understand what a data frame is. Here we're going to create a data frame from a dictionary. So we have this dictionary, and you guys understand now why we had to talk about dictionaries, why we had to talk about strings and variables all before we got here. Now I really think you're getting to like the meaningful, useful content of Python programming, applied content. So here we have a dictionary. Remember, dictionaries are key value pairs. So we have a key name, a key age, and a key salary. And here are the values associated with that. So you can think of these as our columns, name, and our row values. And so we have this dictionary here called data. We're going to take data and we're going to pass it to pd.dataframe. That's all we're going to do. It's pretty simple. We call PD, which is our pandas package. Dot is how you call a function within the pandas package. And this function data frame, capitalization matters here. So capital D, lowercase ata, capital F, lowercase rame. The capitalization matters here. You're just going to pass what you want to convert to a data frame, and then we're going to print that out. I think I have this in a notebook, so we're going to pop out and look at this real quick. Then we'll talk about some common operations. But let's play around with this. Okay, so Python, this notebook contains examples for using popular Python libraries for EDA, etc. All right, so here we have our import pandas as PD. We're going to need to import that. We're going to create, I'm going to break this. We're going to do this up here. Okay. We're going to go one line at a time here. So when we import pandas as PD, as soon as that loads, you can see that doesn't do anything. It doesn't give us an output. It just says, yep, we imported pandas, but we haven't done anything with pandas yet. So we're going to create this data. And if we see what data looks like, we run data. When we have it in a dictionary, it looks like this. And that's not a super friendly way to work with and manipulate our data. And if we wanted to do stuff with it, it would be kind of hard to like get the average and mean and do some data manipulation things. So instead, we're going to convert that dictionary to a pandas data frame. And if we do df here, wow, look at the difference. That's so much easier to work with. It's a little more readable. It's a little more friendly. And now we have a ton of functions associated with this. We can do df.head, which is going to give us the, I know we only have 2 rows here, but normally this would give you the top 10 rows if you're working with thousands of things. And there's other functions we can do here now. So like here we're taking the mean of salary. Let's say we wanted to calculate the average salary. We can very easily now do, let me just do it this way before I even store it in a variable. We can do df at salary, at the salary column, dot mean, and that was so easy to do. And now I have the mean of the salary, and maybe I want to store that into a variable. Now I have an average salary variable that I've stored that into. Great. So this is the pandas data frame. I had one other thing I wanted to, one other thing I want to show you guys here is this as PD is a very semantic thing. So let's get rid of as PD and let's just say import pandas. I just want to show you that instead of using, if you ever see this anywhere else, we can actually, it works the same. So we can say df equals pandas.dataframe. The as statement here is just us renaming this. We could call it whatever we want. Please don't, because that's confusing to anybody else trying to read your code, but we could call it this if we wanted, and then it would be df equals this dot data frame, and that would still work. So the as is just a nomenclature. Typically, people refer to pandas as PD. It's a little easier to read. Okay. Great. So that is what a pandas data frame is. Let me pause for just a second here. Any questions so far on a pandas data frame? Okay, if not, I want you guys to spend 5 minutes on this. You try it. I want you to create a pandas data frame, and I want this to be the data. You'll have to figure out how to represent this. You can use the dictionary example, build a dictionary that has this data, pass it to the pandas data frame, but print the entire data frame, and then I want you to run type on that object. So let's spend 5 minutes on that. And I'm just going to put the banner up, and then I'll make that big again.
when we import pandas, does it import it? It doesn't import it into the notebook. It imports it into Google, right? Our space where we have the notebook.
That's a good question. When you import pandas, Panda should be a package that's already installed on the virtual like compute instance that you're using. But if you have data that you want to pull in, you will have to have that data stored locally and then pull it in too.
Okay. So it basically activates it. It doesn't really.
Yeah, it basically activates it.
Okay, got
Yeah.
it.
Thanks. It is cold in here, isn't it? It's a good idea. I should do a quick little walk. Let's see, I said 5 minutes. Okay, 2 minutes here. Quick little walk. I'll look outside, see if it's storming.
They said it's 82 out there.
82.
Nice one out there.
Hmm.
It was nice when I was out there.
Excuse me, left out from the house, it said it was 88. And that the temperature would be dry. Man, I'm just seeing this email, so I apologize.
It is nice out there. Sure, that's kind of cool. There's a big cloud back there. That's pretty.
Blow up photo.
So cold. All right.
You like hungry, got a bunch of chicken nuggets. Getting full, whatever.
Honestly, that's all I've done tonight is eat. I think I ate trail mix and popcorn and some Oreos and my rice dinner.
It's all the essentials.
Yeah. The main food groups. I'll take a picture of these trail mixes. I know those are our favorite. See if Nick can get some more. So Crystal, these are the class favorite. All right. Okay, let's create a sorry. Let's create a data frame from the following data. So we have, the way that I did this is we have created an ID column, and we have a name, which we have Alice, Bob, Charlie. I think I added some more in here. So there's a couple more names in here. There's an age column, which we're putting here. There's a city column. I guess I put region, but this is similar. I'm just reusing this code. And the way that you would create your data frame there is to call pd.dataframe and then pass in that dictionary that you created. You know, I'm going to simplify this because this is too confusing here. Okay, let's do df my dict to convert. Oh, look, there we go. Alice, Bob, Charlie, 25, 30, 35. And then we had city. And our cities were New York, Los Angeles, and Chicago. So we could do df equals pd.dataframe, passing mydict to convert, and import pandas as pd. There we are. And df.
Question.
Yeah.
Excuse me, so why did you do the body first and not why didn't you do it in sequence, I guess?
Did I do it?
Panda doesn't go in sequence.
Oh, that's a good question. So this data frame here, I think what you're thinking of are functions, because we just talked about functions. I know, and we did two topics in one. So the it is related. This is a function. The data frame is a function that we're calling, but we are not defining this function. This function is already defined by us calling this import pandas as PD. Then it gets defined. So it's kind of hidden because I don't have it in the code, so we can't see it visually. What is this data frame function? And what is it actually doing when we pass it a dictionary? We're abstracting all that code away from ourselves. We can go look at it if you guys want. We can go look at the pandas package and pull that up and find it. But instead, we're just using this function that they have called data frame. And here, the reason that we define this up here is because calling data frame requires a value. So if we called pd.dataframe like this, we'd probably get we don't actually, well, you can create an empty data frame apparently. So that didn't work out quite the way I thought it was going to. But when we when we're creating our data frame, we're passing it the value that we actually want it to convert. So here to the data frame function, we are passing the argument of the dictionary. We're giving it a dictionary as an argument to the data frame function so that it converts that dictionary to a pandas data frame. And then it's actually returning. We just learned about return values from functions. When this pd.dataframe function runs and it takes in this dictionary as a argument, it actually returns to us a pandas data frame. So the return statement on this data frame function inside of pandas is a data frame. So that's the connection between functions and these libraries that we're using.
So you can't enter it last at the input.
Yeah, so we can enter it last. Yep.
Okay.
These are good questions. Okay. Let me pause. Any other questions so far on creating a data frame? Is this landing with you guys? Concept of a data frame so far? It's just another object in Python. We talked about lists, we talked about dictionaries, we talked about strings and integers. This is another data type. It's just not a Python native data type.
Obviously they're position based, but does the app think that Bob corresponds to age 30, or that's just the way they're lining up?
It's a good question. Bob does correspond to age 30. It's what we're assuming. I assume if you give me a row of data and it says Bob 30 Los Angeles, that Bob is 30 years old and he lives in Los Angeles. That's a good question. Okay. I've never seen these buttons before, and I'm a person who's very curious. And so I'm going to click these buttons. I don't really know what they're going to do, but I'm kind of curious. And you should do this when you program too, because I just wonder if this is going to make some charts. Oh, that's kind of cool. Well, that's neat,
nice.
huh?
Yeah, that's nice.
I mean, obviously our data set is only 3 people, so these don't make a lot of sense. But imagine if you had like an actual data set. I'll pull one in here and we can hit
But they
these.
created the charts for you already.
And let me hit this calculation button.
And that created the Excel, sort of.
It did. Huh. Okay, let me unclick this. Okay. Anyways, you should click some buttons when you see some things. Play around with it. Okay. So I wonder what this one does. Oh, it's just giving me a prompt so I can ask AI particularly how to do something. That's cool. Okay, we're gonna delete that. Great, thanks for the exploratory exercise there. So this is a dictionary. What else can we do with, or this is a pandas data frame. What else can we do with a pandas data frame? Some other useful functions. So when I say data frame operations, I'm assuming you have a data frame. What I mean is I'm assuming you created a data frame and you stored it into a variable. So data frame operations means things that you do on a data frame. So if you have your data here, I'm assuming that you did df. You created your data frame. This is a variable. Remember, variables, we can name them whatever we want. We're just going to say df because it's kind of nomenclature. I'm going to assume you did df equals pd dot data frame. Oh man, this is going to take me forever. Data frame. And then I'm assuming that you gave it your data in some format. We looked at how to do it with a dictionary. You can do it many, many different ways. You can read from a CSV. You can read from an Excel sheet. We're not going to teach every nuanced way that you can do it. I would encourage you definitely to explore those on your own and let me know if you have questions. I'm happy to help, but I don't want to dive into 50 different ways that we can do it. So I'm assuming you said PDF is data frame. So when I'm saying data frame operations, I mean, these are the operations that you can do on DF. So this would be, for example, let's look at this first one, inspecting data. This would be DF dot head. Oops. Head. And this will give you the first 10 rows of data. The other one would be DF dot tail. So this would be your data frame dot tail, your data frame dot info. So when I say operations on the data frame, you're calling head on your data frame. You're calling tail on your data frame. You're calling info. So you can inspect your data, and well, I'm sure I have some exercises for you guys. So we can call df.head to get the top set of rows. df.tail will give you the bottom set of rows. That's really useful if you just want to you just loaded in your data in your CSV and you want to make sure it came across correctly. You want to make sure it looks and feels like what you think it is. df.info, df.describe can give you some details. If you want to, a lot of times things people want to do are select certain rows and select certain columns. So if we have all of our data in this one giant data frame, how do I get just that row out? How do I get just the age row and do something with the age row? How do I just get Bob's column out and do something with Bob? You can call df and then your column name. So we would say df square bracket, and then these are string names for your column. So age, close the square bracket. That's how you would select a column. This is probably, I would say, one of the most number one used things, the df column. Similarly, df.loc or df.iloc is going to give you a row. So this gives you a column. I should have another slide for this, I'm realizing. But this, the square bracket syntax will give you a column. Oh, this is terrible. And the iloc will give you a row. So iloc will give you a row. df column will give you a column. Okay. So it's whether you want to go like this or go this way. You can filter your data. So one really useful thing is, let's say we're looking at some sales data and I only want to see sales that are over $50,000. I can say data frame at data frame column name sales greater than $50,000. And I would write all that out, but it'd take me forever to do that. So I'm giving you the general formats here instead of specific things. So df at df your column name, and then greater than or less than or equal to the value you're looking for, and that'll filter your data. There's functions for adding, renaming, dropping columns and rows. A quick Google search will pull those up for you guys. There's functions for grouping by, summing, calculating the mean, sorting the values if you want to sort by a particular column. So you see the most expensive house prices at the top, you can do that. Handling missing data, checking for null values, filling NAs, dropping NAs, and exporting the data back to a CSV sheet or back to an Excel sheet or back, CSV or Excel.
How about regex type of operations? Like we did with SQL, can you assume they're just custom expressions there? How do you use this?
Yeah.
Regex stuff?
You can use regex in Python, and I have many times. I try very hard not to use regex because I don't think it's quite as intuitively readable as some. So if there's some way to be able to do it in Python that's more intuitively readable, I lean towards that. But you can definitely apply regex to search over strings or extract information for you. And it plays well with pandas at the data frame.
If you can use the same Python that's more than 50%.
Yep, and I can even let's do it. You know what I love when people ask questions? Let's just try it out. Yeah.
Sometimes makes more sense.
Okay. This may take me more than just a second, but let me see if I can get a better prompt. And all right, it will take me a minute. It's not giving me a quick example. I thought it would, and I can do this, but I don't want you guys to watch me hop around looking for the exact syntax. What I need is a data set to apply it to. But yes, we can apply regex within Python.
Could you give us an example the next time in class?
Yeah, actually, I'll do it next time we're doing a try it out. I'll give the example then. So I just need like 2 seconds, and then I'll be able to walk you guys through that. I don't want you guys to watch me fumble around.
Yeah, because then.
Yeah, I don't want to get you guys confused. Yeah. So we talked about data frames. The other really core piece of pandas is the series. And data frames are made up of a panda series. So the data frames are talked about quite a bit. Series are talked about a little less, but they're very, very important to understand. They're a one-dimensional labeled array. You can think of a series as a column. You can think of a pandas data frame as made up of a bunch of columns, and the series is the data object that represents a column in pandas. So it holds a set of data, and there are operations that you can apply particularly to a pandas series. So it's really foundational to the pandas data frame columns. I won't go into too much detail about series. I just wanted you guys to be aware of what they are. So as you're working in the program, if it says, gives you an error related to your pandas series, you know that that's a column. That's the piece that I'm trying to connect for you. Okay, so in summary, pandas is used for data manipulation and analysis. It holds our tabular data. We can do a lot of grouping, filtering, aggregating, filling NAs, reading CSVs, and we're going to work with this next class. We're going to do a hands-on data exploration and create some visualization exercise. I wanted to give you guys some context in this class so you know what the packages are that we're going to be working with. So I'm just looking at the time and looking at the clock. We're going to keep going because it's 35, and I want to make sure that we get through matplotlib. I'll briefly touch on, so I think we'll skip the try it for now if that's okay with you guys, but we're going to briefly touch on NumPy, which is another package we can use to manipulate data and store our data. And then I want to talk about our data visualization packages that we'll use next time. So NumPy it stands for numerical Python, is what NumPy stands for. And it's another package within Python. And oftentimes you'll import NumPy and pandas together. You'll say import pandas, import NumPy. Pandas uses NumPy sometimes. So these packages play well together. It's not an either or thing. Usually there's a suite of Python packages that you'll import. Includes NumPy, includes pandas, includes matplotlib, Seaborn, sklearn. We're going to start talking about these. So the difference between NumPy and pandas is pandas has that really nice, pretty visualization. Kind of looks like an Excel sheet. It's friendly to work with. It's got these nice functions. NumPy is really foundational for efficient operations. Not quite as pretty, not as fun to work with, but has things like dot products, which is like a mathematical thing that you do when you're multiplying arrays together. When you're multiplying matrices together. So NumPy is used for, I would highlight here, it's got some pretty sophisticated mathematical functions in it. It's got some pretty sophisticated mathematical functions. So if we're thinking linear algebra, NumPy. And where this comes into play in machine learning and data science is primarily the main application I think of when I think about NumPy is neural networks. So when we get to neural networks, data isn't represented in a tabular form anymore. We have an image, for example, and maybe we can sort of put it in a tabular form. We can say, okay, well, we have an image and I'm going to cut it into pixels. And so here's pixel 1, and here's pixel 2, and here's pixel 3, and this is my image, and that's kind of tabular. That's tabular, but what if I also need to describe something about that pixel? Like, what if I need to describe the color of the pixel? And what if I need to describe like the quality of the pixel? And what if I need to do some other manipulation on that pixel, convert it to gray, know what the edges are, and then add that as another feature? So we could have like feature 1 about that pixel, feature 2 about that pixel, that's supposed to be an F, sorry. Feature 2 about that pixel, feature 3 about that pixel. And now suddenly we don't have 2-dimensional data. We have like n-dimensional data. And that doesn't really fit into a pandas data frame. It's harder to do. It's not quite like Excel spreadsheet. There's more to it. It's richer. It's richer than that. And that happens a lot with images. That happens a lot with video data. So we need something that's not quite as pretty to look at, but is better at performing mathematical functions and can host our n-dimensional data. And that's where NumPy comes into play. So I don't see NumPy, like, we don't talk about or use NumPy for like the whole introduction to machine learning course until we get to like neural networks at the very end is where NumPy comes into play. Okay, so a couple of key features of NumPy: efficient data storage. So just as in, we talked about data objects, just like in pandas, the core object in pandas that you stored your data in was a data frame. In this, it's NumPy arrays. So NumPy arrays are our core data objects and the arrays. They're very memory efficient, and they handle information and can perform operations very quickly, especially on large sets of data. So if you're working with just a huge set of data and it's taking forever in your pandas data frame, that's the time that you might consider leveraging a NumPy array for that data instead. It can be multi-dimensional. So like I said, we're not limited to 2 dimensions, X and Y. We can have many dimensions to our data set, like in the image example where you wanted to describe things about the pixel in addition to just where the pixel was in that location on the image. So we can have really complex data manipulation. And where this comes into play is neural nets. Essentially, everything is represented as matrices in neural networks, and we apply mathematical operations. So when we have a neural network, we'll have like a matrix of data go into this node, and then we'll pass it to these other nodes. And that data, we'll learn in the next course, essentially gets multiplied by some weights and biases like this. And these are called dot product operations. And it generates new output. And then maybe we combine these back together or something. And how this works is close enough. And that's how we get maybe our probability output from our neural network. So these operations here are supported by NumPy, these mathematical functions. Vectorized operations, these are all vectors. And what's beautiful about NumPy is it works seamlessly with other libraries. So this is not an if and or choice. You can use NumPy and pandas and Matplotlib and SciPy. So these are really just all tools in our toolbox. We don't have to choose one necessarily. What does NumPy look like? We like to say as on everything, by the way. So you'll notice we have, again, you'll see the as a lot. You could just import NumPy if you wanted. Oftentimes, when you're seeing examples, it'll be as NP, that's nomenclature. So here is how we would use NumPy. Let's say we had a list, 1, 2, 3, 4, 5, and we wanted to convert that to a NumPy array, because a list is a very efficient operation. And we know that NumPy is much more efficient for numerical operations due to its implementation in C than Python is for lists. So we want to convert this list to a NumPy array. What we would do is we would call NP, so we'd call our NumPy package. We would call array. Similar to in pandas, we would say pandas.dataframe, open parentheses, pass the object you want to convert to a data frame. Here we're doing numpy.array, open parentheses, pass the list that we want to convert to an array. And we're calling that data. We're storing that in the variable named data. And now we can do things with our NumPy array. So NumPy, feel free to explore, learn more about it. I just want you guys to be aware of it. If you see it, we're not going to use it for this class really, but it is a very important package. Okay, very efficient on large data sets, multi-dimensional arrays. Those are the key things. And it has all the same functions, not all the same ones, but it has similar things that you might want to do. You can calculate mean, median on your data, just like you can in pandas. Okay. Let's keep going here. Just checking my time. Okay, 43. This is why I kept going, because I want to make sure we get to visualizations in Python. Creating summary representations of data. Great. So we talked about the two packages that you can use to read in, store your data, actually use your data. What if we want to create summary representations of our data? And why would we want to do that, I guess, I always start with why. Why do we want to do that? We want to create graphical representation of our results so we can identify trends and patterns. We can communicate the insights that we find. We can simplify our complex data sets. We can understand trends. Really, we're trying to create data visualization so we can make decisions. Usually we're trying to decide something or communicate something. I can talk about a really powerful visualization that we made recently for communication. Talk about why visualizations. So we have a model, and our model outputs probabilities. So we have a model, and it will give like a probability that something will occur. In this case, it's like an entity extraction. So it's a large language, it's an AI model, and it's extracting some information from a document. And we're giving a probability that the model's confident that that's the right information. But this is a probability that something will occur. And so your probability can be, it ranges from 0 to 1. So it can be 0.1, 0.3, 0.8, it can be 0.9. What ends up is when you make a model, you usually have like a distribution of probabilities. So maybe you have a few down here close to 0.1. Most of yours are maybe in the middle. This is called a uniform distribution. You might be familiar with this, like a bell curve, where most of your probability, it's actually usually not like this. This is fine. Most of your probabilities are 0.5, and maybe there's a few that the model is not sure on. And maybe there's a few that the model is very certain on. And maybe as a stakeholder, you want to minimize your risk. You want to minimize the risk that you serve predictions into production that the model is not confident on. So what you would do is you would set a threshold. And you would say, okay, well, I'm only going to serve very confident predictions. But what you can see is that we're cutting off most of the data. And so we made this visualization, and by we, I mean one of my team members made this visualization of our data and how it's distributed. and there were two sliders in here. One was for quantity of data, and one was for confidence. And you can basically change these sliders up and down. And it will change if you want a model that's less confident, you're going to get a higher volume. Maybe I should call this volume. You're going to get a higher volume. Model that's more confident, you're going to get a lower volume. So that's visualizations are very helpful. And then basically what we use that to do is the stakeholder got to choose what the threshold was and where we put it, and it was a very informed choice for them. Okay, but we had to make a visualization to do that. And one way that we actually have done that and used in the real world, in true applications, is Matplotlib. So Matplotlib is a very popular Python library for creating static, I'll say static, because not all of them are interactive, though you can do some interactive and animated visualizations, but mostly static. It's very customizable, it's versatile, it's really just a go-to tool, it's really common. There's probably a million Stack Overflow threads on it. And it used to be kind of hard to build, but these days with AI, you can tell it exactly what you want to do, and it's a little easier. You used to kind of have to hunt for what parameter do I have to change to make these lines dotted? What parameter do I have to change this color from blue to red? Now it's a lot easier with AI. I personally, that's been my experience. But this is how we take our data that's in like a Pandas data frame or a NumPy data frame. We can pass it to this package, basically, and it'll create visualization. So here over here on, I'm just checking my time, 8:49. Over here on the right, we're going to import matplotlib.pyplot. This time, instead of importing matplotlib, we're doing .pyplot, which is a subdirectory within matplotlib. That's fine. We're going to import it, though, as plot. Again, PLT. You don't have to do as PLT. You can just import pyplot. This is just common nomenclature, I guess. People do import as PLT a lot. We have our made-up data here. Again, this is like just some fake data. But we're going to call plt.plot. We're going to pass x and y. And then we're going to pass some other configurations that we want to change. So we're making the marker an O. We're changing the color to blue. We're making the line style dashed. And then we can start to add things. We can build on top of this. We can add a title. We can call plot.title and add this title here, and that's how this simple line plot got added there. We can add plot.title x-axis, y-axis, and if we add y-axis, this is how this got added here. If we add x-axis, this is how this got added here. If you think about your visualizations you can create in Excel, this is like the equivalent of that in Python. One question might be, well, why wouldn't we just like export this to Excel and then make the visual in Excel? And you can. That's totally fine. Sometimes your data set's really big. Sometimes you don't want to ship things back and forth to Excel. And sometimes people are just more familiar with Matplotlib. So this is just another tool in your tool belt. You can use anything at your disposal to do this. We will make our visualizations in Matplotlib when we do our exercise on Wednesday. Say again.
Are these libraries free?
Oh, yes. Libraries are free. They're open source. They don't cost any money. And they're quite good. So a lot of common things you can make here: line plot, bar chart, scatter plot, histogram, heat map. These would be things that we play around with, but the world is really your oyster here. Something to know about Matplotlib that I think is important to know as you get started with it. The core component, so we talked about NumPy, the core component of NumPy is NumPy array. The core component of Matplotlib is figure and axis. So the fig and the axis which you'll see a lot, are the main points of this and the subplots. Matplotlib kind of takes like a minute to figure out, but like I said, I think it's a little easier with AI these days. You can kind of create a visualization and then say, hey, how do I add another subplot? Here we're defining the size of our figure and our plots. We are passing our data to plot here on axis 0, x and y1. I think I have this in a notebook. This is like awful to do this on the slide. Marker is 0, color is green, and we're setting the title. Let me see if I have this in a. Let me see. I think this is it. So we're gonna stop at Matplotlib. I'm gonna open this up. There's another library called Seaborn. And then only reason I'm rushing here is we have 7 minutes. So there's another library called Seaborn, by the way, which is another more aesthetic way of making visualizations. So you can use Seaborn if you'd like. We're going to use Matplotlib because I think it's the most foundational package for visualizations. But I don't know. Some people like Seaborn better. Some people like Matplotlib better. They're just two different packages that do the same thing. So Matplotlib is low level, customizable. Seaborn's maybe high level, maybe a little bit simpler, maybe not. Seaborn is a lot more aesthetically pleasing. I found, at least personally, Matplotlib charts are kind of okay. And Seaborn has a lot more built-in functionality and some direct pandas integration. So a lot of people like Seaborn better. I think Matplotlib's a little more widely used, so we're going to explore that first, and then I'd recommend Seaborn after that. Okay, cool. We did get through it all. All right, so let's go look at Matplotlib. I think I should have that in here. Yep. Pandas. Okay, maybe I should have been teaching from this instead of. Let's see. Series. Okay, Matplotlib. So to use Matplotlib, we are going to import Matplotlib as pyplot, or matplotlib.pyplot as plot, and we have some data. 1, 2, 3. I'm gonna make this bigger. 1, 2, 3, 4, 5. What we're going to do is we're going to call plot, and we're going to pass our data. And we're going to put a title on this. Actually, first, I'm not even going to put a title. I just want to show you guys how Matplotlib works. And we're going to call plot.show. Whenever we're done and we're ready to display this data, we have to call plot.show. And here we get our plot. So we have our data, 1, 2, 3, 4, 5. And we're just plotting our data. This is pretty much the simplest chart I think you can make in Matplotlib. And already it's kind of confusing. So I guess Matplotlib is that shows that it gets a little confusing. But what if we wanted to add a title? We can add plot.title. What if we wanted to add a axis? Plot.title. I think it's like x-axis. No. There we go. Plot.x label. So we can add an x label. Let's call it x-axis. We can add a y label. Let's call it y-axis. Let's rerun this. Oh, look. Now we have an x-axis and a y-axis. Look, what if we wanted to add a legend? It's not going to do that for me. Okay. I promise you can. And it's not so easy, or not so, it's very simple. It's very easy. So now let's start to build a slightly more sophisticated chart. Let's add a x-axis, a y-axis. Let's change the color of the line. Let's change the dots to have represent each of our data points and where they're at. So we can start to build more and more sophisticated examples. So we can build bar charts here. What if we wanted a different type of chart? We had ABC, values 5, 6, 7. We can build a really simple bar chart. We can build a really simple scatter plot by calling plot.scatter. And again, some of the syntax is the same. So add the title, add the X label, add the Y label.
So it's forecast.
It wouldn't do the forecasting for you. It's a package that visualizes your data. So it creates these pictures that you see at the bottom here, given the data. So here we have a histogram. We can call plot.hist to create a histogram. And what are subplots? Subplots are when we have multiple plots in one display here. So here we're doing quadratic growth and cubic growth. So we have a couple of subplots here. And then if you're curious what Seaborn looks like, this is what Seaborn looks like. So I think it's just a little more friendly in terms of the visualization that you're getting. It's a little more pleasing to the eye, but really just a different package. Okay, I think we got through it. We did 8:59. Fantastic. I'm going to end the stream, see if anybody has any questions here.